Good morning, everyone. Welcome to week number 5. We're more than halfway through the term now here in Science 200. And apologize for my voice. I have a cold right now. I've been coughing, sneezing. Not COVID. Tested myself. And you're not going to catch it anyway through a YouTube video. But I apologize if I have to cough during this. All right, last week we looked at scientific communication and how the different ways that science is communicated, all the way from research being communicated through scholarly journal articles, all the way down to opinion pieces on websites that you find in a Google search. And there's everything in between. Now, this being said, you publish research in journals because you want other experts in this particular topic to read your work and verify it or critique it or whatever they're going to do. And then you have everything in between. So you can have review articles, which is where usually a scientist will take all different articles about a particular topic, put them together, compile them, and write in a way that most people can understand so that they understand a topic. You have magazines like Scientific American that will take a broad topic, like genetic engineering, for example, and break it down into language that the public can understand. Then you have news articles, news presentations on the internet, on TV. And that's a totally different way to communicate science. And in the textbook, it describes to you that news is usually balanced, so they give positives and negatives. In a journal article, you are not going to find that because you're going to go with what is mostly accepted about a particular topic instead of giving the negatives about a topic, which very few people would agree with. So that doesn't really make any sense. You can mention it, but that is not what you're going to be discussing. Your audience is also important. And you should have chosen your audience for your topic because that determines the language that you use, the concepts that you cover, and how you're going to cover them. If you're talking to a kindergartner, you don't explain to them fully what a black hole is versus if you go before a group of astronomers that are in a conference on black holes, they all understand the topic. So you have to choose your audience and you have to figure out how to communicate to them. This week, chapter 5 is all about biases. Biases in science. So as a researcher, I bring certain ideas to the table because I know about this topic. And so when I set up my hypothesis, when I set up my experiments, I expect something to happen, a particular thing to happen. And if it doesn't happen, if something different happens, then that can lead to whole new channels of research. But I have to realize that. Your clients, subjects, patients will also bring biases if you're doing human studies. They want to tell you what you want to hear. And so it's really important when you're working with human subjects, for example, to do double-blind studies. And that's where the researcher and staff doesn't know what's happening, and your client, subject, patient also doesn't know what's happening. That's a double-blind study. Nobody knows what test material is given to your subjects. That's what happened with the Pfizer vaccine trials, the 2 that I've participated in, happened with my trials. In the first one, I actually got the placebo, which means it was basically salt water that they put in my arm. That trial was opened up when Pfizer saw how effective the vaccine actually was, and I got vaccines then. I also participated in the booster, and with the booster vaccine trial, I was either given half dose or full dose, and right now I don't know which one I've gotten. Apologies for the coughing. Something that we also discuss in science are p-values, which stands for probability or confidence levels. How confident are we that this effect takes place? So if you have a p-value that is very low, that tells you that a particular effect has taken place, that there's very little chance that this thing happened because of chance or just randomness. So you're looking for p-values that are very low, like 5% or less, and a p-value would be described as 0.05 or sometimes 0.01 to give you 5% or 1% chance that this particular effect happened just by chance, just by randomness. And that's what kind of probability values you're looking for. Same thing goes with confidence levels. It's the same thing. You will read about Gregor Mendel and how he set up his pea experiments and how he grew over 28,000 pea plants so that he could look at dominant recessive traits. We didn't understand how traits were inherited until he did this series of experiments over years, which are just mind-blowing even today, because we understand genetics because of an Austrian monk who grew pea plants, which is amazing. What he did, though, really, really important, was characterize each offspring, write them down, and count how many of each he got. And wow, did he come up with some amazing results that we still use today. You know dominant and recessive traits, don't you? You've heard of those. So his genetics experiments were very, very important in the field of genetics. Of course, we know lots more now, and we understand what DNA is. He didn't know how traits were inherited. He didn't know what a gene was. So we've learned a lot since then, but we still take what he found and use it. You'll also be learning about the Deepwater Horizon oil spill in 2010 and how that impacted the environment, the whole Gulf of Mexico. If you don't remember it, you're going to get a history lesson in it and some of the science behind it and how scientists were used to help solve the problem, because it just kept on pumping out oil for days and days and days. And that pretty much destroyed the whole ecosystem of the Gulf of Mexico, and there's still ramifications from it. This week, with your topic project, you are going to revise your rough draft, and you're going to add 2 more sections. So last week you included your principles, your scientific principles, and you explain those. This week you're going to come up with a hypothesis and how scientists could answer the questions presented there. So remember in the beginning you came up with a research question, right? Like, are electric vehicles really better for the environment? All right, that is an overarching type of question, right? Yeah. With a hypothesis, you're going to come down to a much more specific question that you are going to ask about your topic. So your research question was a big question. Your hypothesis is going to be a really specific question that scientists could answer or maybe already have answered. So that's the difference in the 2 types of questions that you have asked and will ask. Your hypothesis is a very specific question that you could design experiments to answer if this hasn't been answered yet, or someone has designed experiments and has answered this question. Excuse me. Use your rubric to guide your work. Fix anything that I've left you feedback on. These are wood ducks that I saw last year when I was down in Charleston. They haven't been hatched yet so far this year when I was down there a couple of weeks ago. And then finally, tip of the week is to use my feedback. I'm giving you feedback every week, especially about your topic. Use my feedback and fix your work. And I go back and look at what I said last week to see if you needed to fix anything and to see if you did fix it. So just realize I'm regrading as we go, and I'm looking to see if you have fixed the work. So please do fix it so that at the end of this, when you put together your final presentation, it will be excellent and you'll get all the gazillions of points that you need to make a really good grade in the class. Okay? So with that being said, I hope that you have a wonderful week this week. And if you need anything, please email me, m.sigmon@snhu.edu. I'll be glad to answer you and answer any questions that you have. All right. Have a great week.